I was thinking about voltage, okay? Remember this stuff? It's talking about, you know, get 3 volts off something like that, okay? And if you have 3 volts times 4, because if you have north and south, you can get 1, 2, 3, 4 off the congruent equidistant north-south 4 faces, like a square kite. Anyway, so 3 times 4 is 12. Cube has 6 faces, 8 vertices for your plus and your x. So I did 14. So 12 times 14 is 168. And because I think that you have to make a one-dimensional line between voltage, current, voltage, I count for 2 of these. So 2 times 168 is 336. And then I previously assumed 120 and 216, but I've corrected it now to 117 volt and 219 volt. Okay? So it's all about this. Okay? But I can't get a... I can't figure out how to make something from a center have a plus and an x. It just kind of seems ridiculous. But I saw this and I was like, okay, 14. Very important 14. So I said, let's this is worth investigating. So again, if that's a square magnet, it's probably easily buyable, okay? You know, cube magnet, north and south, you can get 4 sides worth of springs. Okay, and antenna combinations. So let's say that is equal to a dot, a spring is equal to, or coil is equal to a line, and the antenna is equal to a white dot. So one of these is equal to a 1. We're going to put 14 of these in succession, okay? So now let's just think of the overall construction of the current cube before we get out with the wheels, okay? Like, booyah. 480 millimeters. Okay, but we have to account for the thickness of the walls of the construction material that we're using to fabricate this. We want to create, like, this could be interior measurement. We want to be exterior. So let's look at the millimeter and like the whole thing as a word, okay? So 480 millimeter, okay, really, mm is like, you know, 1313. So if you circle everything properly, you're going to get a 2424 all circled, you know, and then you're going to get, you know, reduces to 13. So, again, need to account for some extra for the thickness of the cube. So 400 millimeters is equivalent to 480, 13, and no circle intended. So 480 plus the 2 circles here. You can't circle the 0, it's already circled. Plus the 13 is 495. Now this is interesting. 14 divided by 495 is 35, 35, 7, 14, 28, 571. 571. It repeats. This pattern keeps repeating on this random calculation. Now, what that means is like Armageddon code, 3 makes 4 makes 5 centimeters, is approximately equal to 35.35 millimeters, which is the distance from magnet to tip. So it's only 3.5 centimeters. It's not big. They're really not big, guy. They're tiny. There's that repeating pattern again. So what I'm thinking, okay, is basically something like this, okay? You're going to be putting 14 in a row, 14 in a row, 14 in a row, 14 in a row, and you're going to create 4 corners of the earth to house this inside. So this is going to be on the inside of this. Reason I want to leave 2 faces off, because it's always good to have light coming in to make your, who knows, hologram cellular energy device. Now this is important, okay? We still have to worry about, like, again, there are 14 axles rotating, okay? I forgot to depict, you know, the ones on the corners, guy. Okay? But I didn't do that here. Okay, so this is what you're going to have. You're going to have 14 axles. That means that 14 wheels, they're each going to need 336 volts. And if you're able to get 336 volts, okay, out of yeah, so let's count, because I didn't do that yet. Sorry, I'm way ahead of myself. So if each one of these black and white dots is 3 volts, and you have 14 of them, and you have 4 of them. Let's check it out. 3 volts times 14 is equal 42. You're going to multiply that by 4, because you have 4 sides of your square. 168. You need 2 of those. 336 minus 117. 219. Okay, so that's interesting. Okay, the way I thought it then. Okay, so originally, let's just start from the beginning. So on every one of these right here, you're gonna have 1 3-volt. 1 3. That's where the other 2 come from. That's where the 2 come from. That's where this 2 comes from. Okay, good. Because, perfect. Yeah, you have 2. Because you're going to have a magnet going to an antenna for 3 volts. And then you're going to have a magnet going to an antenna for 3 volts. That's going to be your 6 volts. And then your next 6 volts is going to come from this guy. But really all you've done is 1 hop, 2 hop. Okay? And you got to do 14 of those. So that means this distance, this distance is going to be 35.35 millimeters. Interesting. And I think your these guys are gonna have to be like, you know, like elbows for a coil to turn on one side and a coil to turn on the other side and keep them apart. Okay, so there you have it. So that means that, good. Okay, every hop from here to here is going to be 6 volts. Okay, so you're gonna get 6 volts. Okay, now do that. 6 times 14 times 4. 6 times 14 times 4. Oh yeah. Okay, good. So that means you're 14 wheels, because you're gonna have 14 rows here. 14 rows, or 14 rows, all separated. Okay, we're gonna have wood spacers. Okay, we're going to put wood blocks like Jenga blocks. Jenga. Okay, so that they're insulated from one another. So that the wires coming between, you know, each of them, or like basically one at the end and one at, I guess they're all going to be as one. So series is just, you're going to take wires off there, wires off there, wires off there, wires off there. It's not hard. That's 14. Okay. So yeah. 2 times 3 is 6 volts. 6 times 14, 84. Right? 84 times 4, 336. 336. Now this is cool. 30. So yeah, I forgot. So you're gonna have 14, basically 1, 2, 3, 4, 14 one-dimensional lines that I've shown to you as circles. So you're gonna have 14 fours. 144. Well, what's a 4? 4 is just a circled 3. Not really that then, eh? That's just a circled 1, 2, 3. Anyway, in like X, Y, Z, you know? The circles that go around the X, Y, Z, 144,000. You know what I'm saying? Maybe this is like an antenna configuration, you know, if you have all your antennas coiled around 14 times like a paper kite, maybe it'll like project. Anyway, there. This is ridiculous. Knowing that I needed more space, okay? Because like, you know, your pieces are going to be a little bit thick, right? You know, a little bit thick. So then you're going to have to put this stuff on the outside of that. So 480 millimeters becoming 495 millimeters. It's only 1.5 centimeters, but 1.5 centimeters is 3/4 centimeter in either direction, and that's not bad. Armageddon centimeters. This pattern, again, like what are the chances of this guy? Yeah. It's Jenga blocks in between, literally. And that's what this is. This right here with a grid of 2-dimensional planes, 14 of them, cutting through it. Seriously, guy. I'm actually being serious. 14 of these going around it while that's spinning. Hopefully encompassing... I guess the axle can go... who knows? Maybe it has to encompass all the wheels, maybe not. But at this point, I'm just doing the bare bones cell. The numbers are very interesting. And check it out, okay? Remember this stuff? This stuff right here? All these numbers are represented on this paper, okay? It goes like this. The center is your air. That's your octahedron. Your octahedral light source for your four corners and your two in and out of the plane, okay? Then you have to leave a line of space, okay, up here. For this next guy. This next guy right here is your icosahedron. And icosahedron has 20 faces. Look at this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 faces. Interesting. 12 vertices. Okay, so how we count 12 vertices? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You have 4 sixes. I don't know, maybe because you have duality because of the octahedron. It somehow equates to 12 instead of 24. Anyway. And 30 edges. Okay, well, 6... 1, 2, 3, 4, 5, 6 times 4. I don't know. That's not 30. But anyways, I think this is your icosahedron is this black square. Okay? And then this one right here is your dodecahedron. Yeah. I think going on here. Okay, and after the dodecahedron, you're going to have your cube, your earth, your square. So if we're on the brown point here, which is dirt, or like, you know, we're going to have a square. Where's our square going to be contained? Okay, it's going to be contained a unit of space and then a unit of square. Hey, look at that, there's our square. We have 4 of them. We have one here, one here, one here, one here. Okay, a cube has 6 faces. Okay, well, 1, 2, 3, 4, top and bottom 6. It has 8 vertices. I don't know, 1, 2, 3, 4, 5, 6, 7, 8. And it has 12 edges. I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There you go. Here's your cube. And your tetrahedrons are the yellow things inside. You're going to have 1, 2, 3, but 4 faces. 1, 2, 3, 4. That's your fire. Fire, earth. Okay. Spirit. Water. Air. Black hole. Okay? So, literally, this is a two-dimensional depiction. Minus, like, you know, maybe it is 14. Because look, you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so 14. This is the current, and also a depiction, because 14 sheets going through this. Okay. Again, I don't know if all of these wheels, extra wheels, are contained in here or not. I don't know. So, yeah. I don't think they are. I think these wheels are on the outside now. But, either or. Like, these are just thoughts, guy. I went for a walk and got a coffee. And I came back and I thought about this number. And I thought about doing this. And I thought about dividing. And literally, it's just going to be, like, it's going to be taking a magnet, okay, a little tape on it, putting a coil on it, screwing in an antenna, coil, okay, insulator, magnet, repeat. With